Okay, today's lesson is on factoring polynomials, and this is our second time doing this. But before we get started, I have a riddle for you. What do math teachers like for dessert? Pie! Okay, anyway, let's go ahead and get into our lesson. Um, Remember, we already learned the difference of two squares. For a squared minus b squared, that's a plus b times a minus b. Now I'd like for you to consider what happens if there's a plus sign here. Okay, and we get a plus bi times a minus bi. If you multiply a plus bi times a minus bi, what you'll find is when we do first, we get a squared. Outer and inner will cancel. And then for last, we get a negative b squared I squared. And let's recall that I squared is negative 1. So that's how we get the plus 1. The negative times the negative. Plus the b squared. So that's how that formula is derived. Now you'll notice in the book they're not going to show you that. Normally you learn that in pre-calc. But you guys are advanced and I know you can handle it. Let's start with the difference of two squares. Let's do a few examples. Here we have two terms. We check to see if there's a GCF. No, there's not. So you want to take the square root here, which is x, and the square root here, which is 11. And you do 1 plus and then 1 minus. And it's just that easy. Now, let's go to part B. We check to see if there's a GCF. Let's see, 3 goes here, but not here for no GCF. So continuing on, we look for the square root here and the square root here. So that's 3x. The square root here is 8. So we do 1 plus and the same thing, but with the minus sign. And it's just that easy. We have the first power on both of our x's. Now, if we look here, you might say, well, 7's not a perfect square. But I just ask you, what's the square root of x? And what's the square root of 7? The square root of 7 is just the square root of 7. Make one of these positive, one negative. And that'll be just fine. I check for the GCF, and it is 4. Now, one might be tempted to just start taking square roots, but you always want to take the GCF out first. So that leaves me with 4x squared minus 1. And now I take the square roots, and I see that leave the 4 out front, and that's 2x. The square root of 1 is just 1. And I do 1 positive and 1 negative. And it doesn't matter. You can put the negative first. I'm just kind of used to doing the plus sign first. Now, let's practice a few problems with the sum of squares. It's almost just the same. You're still taking the square root. But now, if it's a plus sign, you're going to have to do 3i. Just tack that I on there. And, oops, we're still going to do 1 positive and 1 negative. And it's just that easy. We're done. Alrighty, part B. Is there a GCF? No. So I'm going to start taking my square roots. That's 6. And that's 6. Square root here is x. And now that's a plus sign. So I know I got to have my i's in there somewhere. But what's the square root of 5? Square root of 5 is the square root of 5. And I need the I. But remember, we make the radical go last. I need 1 plus and 1 minus. And I'm just looking over this to make sure there's no GCF that I forgot. And everything looks simplified. I got a plus sign, so I need my I's. Yep, looks good. Okay, again, I have the plus sign, so I know this one's going to have imaginary after the plus and minus. So the square root here is easy. That's just x. And let's see the square root. Don't forget the i's because this is addition. Oops. And so that's the square root of 20. But we have a little issue. What's the square root of 20? Remember, that simplifies to 4 times 5. That's our perfect square, and the square root is 2. So that's 2 radical 5. So we want to write this as 2i radical 5 and x minus 2i radical 5. Alrighty, that was a pretty good problem. Now we're going to look at what do we do if we have the sum or difference of 2 cubes. And I'd like for you to memorize your perfect cubes, because if you know your cubes, then doing a cube root is very easy. So, for example, the cube root of 125, we can just look right here and say, oh, it's 5. So they work just like square and square roots, but now we're looking at cubes. And we'll explore cube roots a lot more in upcoming chapters. Look at these 2 formulas. I want to let you know that if you distribute the A out and the B out and combine like terms, it will definitely end up just being A cubed plus B cubed. So this is how we start to factor the sum and difference of cubes. There's a little issue with this formula. This second part right here and right here usually have imaginary roots. Okay, so we won't factor that. You'll learn more about the imaginary roots and how to find those in pre-calculus. And I'll just give you a hint. You need the quadratic formula. Okay, so now let's work a couple of examples. Let's factor x cubed plus 64. The first thing I always do is check to see if there's a GCF that can come out. And no, there's not. And I do notice that that's a perfect cube. If I take the cube root, I get x. And if I take the cube root of 64, you can look and see that that's just 4. So x got cubed and 4 got cubed. So the good thing about that is when we look at the formula, A plus B, well, A cubed plus B cubed, I'm going to write it again just so you can get used to seeing it, is A plus B times A squared minus AB plus B squared. And what you'll notice about this formula is that this first little piece will always have the same sign, but that next sign is the opposite, and the last sign is always positive. Always positive on the B squared. So this one has the same sign and opposite sign. Okay, same, opposite. So we want to start getting used to that formula. So now for this problem, A is going to be our x and B is going to be 4. So now we're going to plug x in for all the A's And we're going to plug in 4 in for all the b's, okay? So what that gives us is x plus 4. And now x squared minus x times 4. And I'm just putting these in parentheses just so you can see that I'm just making some substitutions right into that formula. The more you practice, you'll be able to skip that step. So I get x squared minus 4x plus 16. Final answer. Be careful. Some people, for whatever reason, like to add a 2 in there. Don't do it. No, no, no. That's for perfect square binomials. Okay. Let's go down and do this one. What's the first thing you look for? GCF. And I see I have a GCF of 3. So I end up with 8x cubed minus 1. And now I'm down to 2 terms, and I start looking for the cube roots. The 3 is still out there. The cube root here is 2, and the cube root here is x. So x got cubed, 2x got cubed. And here, the cube root is 1. So I can quickly see that my a is 2x, and my b is 1. That's a positive 1. This negative here is just a part of the problem. So that lets me know to use this formula. But always make b positive. Positive, positive, positive. As a matter of fact, I'm going to let you know. Always positive. That's a mistake that students want to make that b negative 1. No, it's positive. So this formula is a minus b times a squared plus ab plus b squared. If I were you, I'd try to write each formula 5 times without looking. That'll help you memorize. Nonetheless, let's get to the problem, and we're going to start substituting 2x in for all of our a's and 1 in for all of the b's. So I get 2x minus 1, 2x squared. The parentheses are actually very important on this one. 2x times 1 plus b squared. So here, I'm going to simplify. And when you square, don't forget to square the 2. Students often forget to do that. So that becomes 4x squared plus 2x plus 1. And remember, don't try to factor this part. It has imaginary roots. And you'll learn how to factor that in pre-calc. Okay? So we're going to stop right there. Boop. Alrighty, let's proceed to example 4. Well, first of all, let me tell you that there's so many different types of problems that you'll learn how to factor. I'm just showing you a lot of different examples so that when you see a problem in the future, you might recognize a pattern. Here, this is a trinomial. So whenever you have a trinomial, you start by looking for GCF, and then you think diamond. Now, you might say, but that's the 4th power. That's okay, as long as this one is twice as much. Okay, so that's got to have a double half relationship. If that's true, you can just do a regular diamond. Negative 28 on top, negative 3. So that's 7 and 4, negative on the 7. But now, the one that's in the middle, that's what you're going to do. So that's x squared, and that's going to be a minus 7 from the diamond and a plus 4. Now, here's the thing to realize is that we're not done. Now we have the difference of squares. So that's going to be the square root there is x, and the square root there is 7. So x plus radical 7, yeah, that's a radical 7. So remember what we did in example 1. And now we have the sum of squares. See, this is where it gets fun. And so the square root there is x plus 2i and x minus 2i. Remember, when we have the plus sign, we have to do the imaginary. When it's subtraction, you don't need the imaginary. And notice I have all my x's down to the first power, and boom, I have factored that completely. Alrighty, let's do one more example. Here, I'm looking for GCF first. There's no GCF. However, this is the difference of two squares. It's not a trinomial, so no diamond. But these are all perfect squares. So the square root here is 4. The square root here, just cut it in half. As long as that's an even exponent, it's really easy to cut that in half. And the square root here is 9. So I'm going to do 1 with 4x plus 9. 4x squared. And then minus 9. And now we need to continue. We have the sum of perfect squares and the difference of perfect squares. So you want to keep going until you get all your x's down to the first power. So I'm just taking square roots again. So that's 2x. Oh, this is a plus sign. Means I need imaginary. So that's plus 3i and 2x minus 3i. And now I'm doing square roots again. Square root, square root, square root. So this part is going to be 2x plus 3, 2x minus 3. I don't need the i's because it's subtraction. Subtraction, no I. It's just when you have the plus sign that you need the I. So I'm all done with that. And we could multiply all that stuff and distribute and combine like terms, and we'd get right back here.